Hello, my name is Sam, and this is my Hack the Track Hackathon project. You can just go to my website right here, click on Hackathon, track, select one of your tracks. Each different track has its own pictures. Select a race session. These two track and race sessions each will provide its own unique vehicle ID, and then each unique vehicle ID will have its own starting lap. So let's just go here. And before getting started, every single time if it loads and someone hasn't used this in a bit, the API will probably take 20 to 30 seconds. And then after that, you just have to refresh the page and come back to this hackathon, and it should work quickly on the second try. So click predict. So you see the predicted times for these starting laps and how many laps it predicts. Okay, let's see how well this did to the true values. Okay, this pre-event shows the true values, and you see the predicted lap time versus true lap times. Okay, well, that's interesting. Should I have pit or not? By clicking this real time, you see the pit stop times versus no pit stop times using this average pit stop time right here provided. And given out the graph, I would recommend not pit stopping as it provides no benefits for future use. Okay, well, let's see. How does this model do in this specific session? So for this specific session, just clicking lap 5, predicting 5 laps, the model did pretty well. And you can see the generalization and the mean squared error right here. And there's also a trend line seeing the race car decreasing after each lap, which is good. Okay, well, how did this whole race do? Okay, well, this is interesting. What do invalid laps mean? So this min lap time is ensuring that each of the laps or at least greater than 60 seconds, because if it's just 0, then there's invalid data, and like that doesn't make sense. So if you see 60, you see this 63 right here on this race car. If we put it to 70, it'll be added to that, so you no longer see the 70. So stuff like that, and you can see that the none invalid laps will be the true finishers versus the DNF, and or if you want to take invalid laps into account, you could do more data analysis on what went wrong with those laps for why those laps are less than 70. Okay, well that could be useful. What about a new race session? I want to know Barber, test new car. I want to predict 10 laps, but I want to give the first 2 laps like 150, provide all these needed, but the only ones with asterisks are needed values, and you don't even have to add them. And you can predict a whole new whole race session. You don't even have to use like one of the past ones, and this one can tell you how you did. And that's for showing off all that. I could show others, but that's pretty much everything needed. But for example, I could do Sonoma, race 2. Let's just say this one, starting lap 1. And we want to predict 2, predict pre-event. Not much, but doing it here, we could say that it is definitely required or recommended to pit stop as compared to the other one. This is a huge strategic point right here if you were just to continue. And you can just like post event, weak agreement. This provides insight on how like well the model did, and race results. These two are like don't rely on the predict at all. Just show another one, Lakota. Let's go race 1 again. 8-6. Let's just go with this one. Starting lap 1. That's what we want to predict 10 laps. Click the predict button. Pre-event. Can show like a whole thing here. As you can see, there's like NA here. So if the min lap time is like less than 25, it will use the predicted to plot on this point so it doesn't mess it up. And you can see like there's big errors here. So you can see like what went wrong here. This is what the model predicted. It was doing fine for the first 2 laps and it like fell apart there. So something must have happened there. And then predicting pit stop versus no pit stop. You can see that the consideration of pit stopping here, but it might, so big advantage to that. Post event, obviously, this model isn't as good as the other tracks, but these errors obviously loosen it. For example, if you started at lap 5 and want to predict 5 laps, this model would have done better. And that's my project, showing it off. Hello, this is the presentation for my hackathon. Not really needed, but thought I'd provide some background to my project. If you continue watching after the third 3 minutes, it's not needed, just shows all the details that went into this project. A little section, introduction, inspiration, roadmap, the typical stuff. Here's a little bit more about me. I'm a student and part-time co-op. I'm a graduate student at Louisville. I'm doing a part-time co-op in information security at UPS. Coming into this with no racing knowledge. I've experience in full stack development. My data models is just from my data mining class, and I like to spread positivity around, and I recently got engaged. So I'm about to share that to the world. So curiosity meets machine learning, a data mining problem. So my whole idea was to build a smarter racing application that anyone could use. I wanted to see like a data alone can uncover strategy and provide like association between the two, like how like racing is very complex and providing that into easy to read insights. So step 1 was researching the data, not just the data, but like race cars, the tracks, like how they work, creating the ML predictor models. That every step took 1 week, and it was a lot of work. Developing backend API, that was with a Python Flask model, then saved with Azure Web Service, which I'll talk about more. Implementing front end using the backend API, the lifecycle process. Like I would notice something in the UI, and then I have to like re-go back to the like step 2, and then go back to step 3, step 4. So that was a whole like cycle through there. But right now I'm currently on step 5, doing this presentation and all stuff like that. There were some challenges, unpredictable and inconsistent data. If you were to notice, I didn't do one of the tracks because one of the data included like JSON strings. I just didn't want to do with all that. There was a ton of feature engineering I had to do, validation checks, pre-process pipelines, like high parameter tuning. I had limited time, as stated earlier. I'm a graduate student, full-time, taking like 600 level classes right now. I'm doing a part-time job, UPS for information security, like 20 hours a week. And there was a ton of complex front-end logic and frequent errors. as you can notice in the UI, if we were to use out my app like right now, since the whole world can see it, there was a lot of edge cases, state handling, error messages, so to provide like a more stable, intuitive interface. So I call this the GR PaceCraft, which is a real-time race strategy engine. It's built specifically to tackle this challenge, to uncover that development process and provide like actual insights to this. And this is all in real time, and can give drivers and team strategic edge, like when to pit, when to not, like how is do, and provide like, hey, this model predicted this, but like we're 40 seconds off. Why is that? So in terms of the machine learning models, and the data pre-processing step was a huge. There was feature engineering, like creating my own feed columns and stuff like that, like the last 3 rolling averages. Hyperparameter testing, there's like 1,000 combinations to use, like number of trees, leaf size, and items, stuff like that, like max features, min sample split, max depth was one of them. Normalization, for example, if I want to use standardize or robust scaling, or like if I want to fill in using the mean versus the mode for missing values and stuff like that. And selected intervals, there were a lot of outliers. It's like some of the data for some reason included like lap times like less than a second, and that's just impossible, or lap times are like 600 seconds, which is just weird. So I had to do like selected intervals for each track model, and the goal was all completed for that. For the barber track, the R squared value, this R squared is actually for just generalization. This is root mean squared error. So for example, the model will only be off by 1.18 seconds plus or minus that. So higher value for generalization means it's able to do 97% of the data values given. It's able to generalize 97% of them. So that's really, really good. And this mean squared error is really good. Obviously, every second counts in race cars. And this provides the average lap time for the model, and the interval selected, like it only predicts between 80 to 150. It will never go outside those bounds. And you can see through each one of them. For example, Coda has a pretty bad, but and Sonoma has a pretty bad generalization score. This is the entire high-end overview. For example, creating the machine learning models. It's a whole separate process with the data pre-processing and saving that, and then I use that saved model, put it in the API Flask Python, and I tested that locally. And then once I tested that locally, I put it on Azure, and then I used an internet connection or post. I tested it via Postman as well, but I used Angular for the front end and just used GitHub web pages, hosted it for free. Everything's free. It just took a lot of time. I use Azure free web app services, and Angular. Angular is free. I can develop that locally, and GitHub web pages is free to use. So this sends users inputs, and this user inputs get used here, and this output gets all the way through there. Next steps is to clean up the UI. After playing the UI, there are still some UI errors that are annoying, but we'll need to fix and have more extensive testing. That can be done soon. That can be done pretty easily though. Expand future races. For example, instead of having the user insert each lap by one, the user can just insert like an Excel spreadsheet, and they can predict from there. It makes it much faster and easier and not like monotonous. Train models on more data. For example, if you saw a pretty bad RMSE score for that one, I think it was Coda for like a 10-second, we need to pull from like 2023 and 2025. And then last one is comparing models to a real-time race, like seeing how it does in like the next year's race. And any questions, just email me. That's my whole project.